Example number 1. A vehicle goes into a road with dips and humps. It brakes to produce a uniform deceleration to adjust with the road. At point A, the speed of the vehicle is 100 km per hour. Yun yung dip natin or yung palalim. And 50 km per hour at point C. Yung point C natin, yun yung hump. Point A to C has a distance of 120 meters. If the vehicle experiences a total acceleration of 3 meters per second square at point A, and if the radius of curvature of the hump at point C is 150 meters, calculate letter A, the radius of curvature at point A. Letter B, the acceleration of the inflection point B. Letter C, the total acceleration at point C. Para mas ma-visualize natin yung problem, this is our figure. So, from point A, nandito yung ating dip. And sa point C na naman, nandito yung ating hump. And from A to C, meron tayong total na 120 meters na distance. Let's solve first for letter A, the radius of curvature at point A, this point. Para mag-fit yung ating given to other given values, ay convert muna natin yung ating velocity at point A and ating end velocity at point C from km per hour to meters per second. Yung velocity at point A natin, we have given a 100 km per hour. And converting in meters per second, ang magiging value niya ay 27.8 meters per second. Velocity at point C naman, converting from 50 km per hour, ito ay equal sa 13.89 meters per second. And to continue solving for the problem in letter A, we need to find first the constant deceleration along the road natin. Since given naman na sa atin yung velocity natin at point C and velocity natin at point A, magsiserve yun as the final and initial velocities respectively. And meron na rin naman tayong given na total distance na 120 meters. Using our equation na V dV equals A times ds natin, yung acceleration natin dito na magsiserve as constant deceleration, this is our A tangential. Again, A tangential po ito. And to solve for that, we have to integrate both sides. And by integration, the integral of V dB from velocity at point A to velocity at point C is equal to the integral of A tangential natin, yan yung ating may constant deceleration, times ds from 0 to s. Since magiging constant na to at siya ang hinahanap natin, pwede na natin siyang ilabas dito. So, continuing here, this is the integral of V dV from VA to VC equals the A tangential natin or the constant deceleration natin times the integral of ds from 0 to s. So, dito nang galing yung ating equation, and by deriving this equation, we will get that A tangential natin or the constant deceleration is equal to VC square minus VA square over 2 times S. So, ito rin yung ating mga formulas natin na ginagamit pa natin noon sa physics but with different derivation. Substituting the values, we have velocity at point C, 13.89 meter per second square minus 27.8 quantity square over 2 times 120. So, obviously, makukuha natin dito is a negative value. And, kaya nga sa tinatawag na deceleration kasi it goes negative. From malaking velocity to papaliit, big sabihin, bumagal. And the acceleration tangential natin or the constant deceleration natin is now equal to negative 2.41 meters per second square. And this is not our final answer yet. Ang tinatanong for letter A is the radius of curvature rho at point A. With the total and main acceleration natin na given sa problem, we have 3 meters per second square. Siya magsiserve as, with the main and total acceleration natin na given, yung 3 meters per second, siya magsiserve as the A. And this is 3 meters per second square. And alam na natin yung A tangential. We have eto, negative 2.41 meters per second square. Since the formula for our rho, we have an equation AN is equal to V square over rho. Alam na natin ito. And ito ang hinahanap natin. Yung rho or yung radius of curvature natin, we need to find the value of the A normal natin. And ang gagamitin natin of course ay ito with the formula A is equal to square root of AN square plus AT square. Solving for AN is equal to the square root of A square minus A tangential square. Substituting the values, we have AN is equal to the square root of A natin is 3 meters per second square minus ang AT natin is negative 2.41 meters per second square. AN is equal to 1.785 meters per second square. Again, this is not our final answer yet. Ang hinahanap natin is the radius of curvature, and using finally this formula, rho is equal to V square over AN. Rho is equal to, ang V square natin, ang velocity natin na gagamitin ay yung nasa point A of course, velocity at point A. 27.8 meter per second quantity square over ang AN natin na 1.785. Finally, ang radius of curvature natin is equal to 432 meters sa point A. For letter B, the acceleration at the inflection point B. So if you can notice, ito yung ating first curve. And this is the point A. This is the point B. Yung nakuha natin na normal acceleration kanina at point A, we have 1.785 meters per second square. Ito yun. So this is our AN na ang value ay 1.785 meters per second square. And of course, yung ating acceleration tangent we have here. So this is our AT na ang value is negative 2.41 meters per second square. And of course, given naman na sa atin kanina yung 3 meter per second square na total acceleration, and ang position ng total acceleration na yan is dito. This is our total acceleration na makukuha natin by Pythagorean theorem. Okay? Since yung radius of curvature natin since yung ating radius of curvature ay infinite at the inflection point, kasi itong point B natin, siya na yung hangganan ng first curve natin na ito, and yung kadugtong natin dito sa point C. Therefore, wala tayong normal acceleration at point B. So, ibig sabihin, ang AN natin dito ay 0. Ang tinatanong sa atin for letter B ay yung acceleration at inflection point dito sa point na to. Wala tayong normal acceleration, pero meron tayong tangential acceleration. At yung tangential acceleration na yun, naiisa lamang din kung ano yung tangential acceleration dito, siya rin yung tangential acceleration dito. So, meaning, we have tangential acceleration here is equal to negative 2.41 meters per second square. And dahil 0 ito, to find the total acceleration at inflection point B, we have A is equal to square root of AN square plus AT square. A is equal to, dahil 0 na to, we can already cancel this one. The total acceleration at inflection point B is negative 2.41 meters per second square also. So this is the answer now for letter B. Letter C, the total acceleration at point C. Again, we are asked to know the total acceleration, meaning, kailangan muna natin hanapin yung normal acceleration at saka yung tangential acceleration at point C. So, considering this is the curve, and this is the point C, ito yung ating normal acceleration, and of course, this is our, nakadikit dyan, this is our tangential acceleration na ang value ay negative 2.41 meters per second square. Since alam na natin ito na lang kailangan nating hanapin. So, the normal acceleration becomes, we have the formula, an is equal to v square over rho. We have another given na radius of curvature at point C. Ito yon, 150 meters. And alam naman na natin agad yung velocity at point C. So, we just substitute para makuha natin yung value ng normal acceleration. Normal acceleration is equal to ang ating velocity at point C. We have 13.89 meters per second quantity square over ang rho natin, we have 150 meters. And by calculating, normal acceleration is equal to 1.286 meters per second square. Hindi pa yan ang final answer. So, with the unit vectors na en and yung et natin, in the normal and tangential directions, yung acceleration may be written as, kung gagamitan natin ng unit vectors, for normal and tangential components, the total acceleration can be rewritten as 1.286 positive yan, en minus 2.41 et. So minus kasi negative, eto yan, meters per second square. Pwede natin i-write as ganito. Kung in terms of vectors yung required sa atin. But since ang nanap sa atin is the total magnitude of the acceleration, we have a is equal to the square root of ang a. We have solved the normal acceleration. Ito yan. Square root of an square plus at square. And substituting the values, we have acceleration is equal to, ang an natin is positive 1286 meters per second square, plus tangential acceleration na negative 2.41 meters per second square, quantity square. And ang magiging sagot natin for total acceleration ay 2.73 meters per second square. This is the total acceleration now at point C. And again, reminder, kung in terms of vector ang hinanap sa atin for the acceleration, ito yung magiging answer natin. Same with the principle of for the rectangular components ng curvilinear motion. So this is example number 1, letter C. Example number 2. A rocket maintains a horizontal movement of its axis during the powered phase of its flight at high altitude. The thrust imparts a horizontal component of acceleration of 20 feet per second square, and the downward acceleration component is the acceleration due to gravity at the altitude, which is the gravity is equal to 30 feet per second square. At the instant represented, the velocity of the mass center g of the rocket along the 15 degrees direction of its trajectory is 12,000 miles per hour. So, this is our figure. Ito, yung mass center G is located here, at the center of the gravity of the rocket. We have 4 questions. For this position, determine, letter A, the radius of curvature of the flight trajectory. Letter B, the rate at which the speed v is increasing. Letter C, the angular rate beta prime of the radial line from G to the center of curvature C. And letter D, the vector expression for the total acceleration A of the rocket. We can observe at the figure that yung radius of curvature natin appears in the expression for the normal component of acceleration. Meaning, isa lang yung line ng radius of curvature natin and of course yung ating normal acceleration. So, we use the normal and tangential component to describe the motion nung center of G nung rocket natin. Yung normal and tangential components natin of the total acceleration ay maaaring makuha by resolving the given horizontal and vertical accelerations into their normal and tangential components and then pagsasamahin natin. Before we go to the radius of curvature of the flight trajectory, of course, we should first solve the normal acceleration and the tangential acceleration. For an, looking at the figure, we have here 30, considering downwards as positive, yung 30 feet per second square natin ay magiging positive 30, and since itong 15 degrees na to, equal din dito, we can write this as 30 cosine 15 degrees. Ito ang ating AN. This is the 30 feet per second square. Ito yung 15 degrees natin. And the 20 degrees natin ay located here. 20 feet. Yung 20 feet per second square natin ay located here. And ang angle ay nandito, 15 degrees. So by summations of the accelerations natin, for AN, we can get that AN is equal to 30 cosine 15 degrees. Considering downwards again as positive, this is minus 20 feet per second square sine 15 degrees. AN now is equal to 23.8 feet per second square. And for 80 naman, 80 is equal to 30 again. And since ang location ng 80 natin ay etong part na ito, and 30 feet per second square, magiging sine 15 degrees naman siya kasi re-reverse natin. Sine 15 degrees plus 20 cosine 15 degrees. Parang ganito ang ginawa natin, kaya lang in an opposite way. So, therefore, the value of the tangential acceleration natin is equal to 27.1 feet per second square. This is our AN and this is our AT. For letter A, the radius of curvature of the flight trajectory. We have a formula for that. AN is equal to V square over rho. Na-solve na natin kanina sa previous page yung normal acceleration, which is yung 23.8 feet per second square. And we have already given the velocity ng ating rocket na 12,000 miles per hour. But we should first convert yung ating magnitude ng velocity para mag-fit sa equation. And by converting, ang velocity natin initially is 12,000 miles per hour. Converting, this is equal to 17,600 feet per second. And using this formula to solve for the radius of curvature, rho now is equal to, ang V square we have 17,600 quantity square over ang AN natin at 23.8 feet per second square. And by calculating, radius of curvature is equal to 13,001,126.05 feet. So this is the answer for the radius of curvature of the flight trajectory. For letter B, the rate at which the speed V is increasing. The rate at which yung velocity natin increasing is simply the acceleration. And that acceleration is a tangential component of our acceleration na na-solve na natin initially before natin i-start yung letter A. So we have V prime is equal to yung tangential acceleration natin, and ang tangential acceleration natin ay 27.1 feet per second square. Ito na yung ating rate at which yung ating velocity V is increasing. This is already the answer. To letter C, the angular rate beta prime of the radial line from the center G to the center of curvature C. Yung angular rate natin na beta prime of line ito, G to C, ay nakadepende dun sa ating velocity and dun sa radius of curvature natin na given by the formula, velocity equals rho times yung ating angular rate na beta prime. And solving this, beta prime is equal to velocity over rho. Substituting the values, ang ating velocity kanina, we have 17,600 feet per second over ang ating rho na nasolve na rin kanina, 13,015,126.05, and we can finally solve the value of the angular rate natin. Angular rate beta is equal to 13.52273 times 10 raised to negative 4 rad per second. Ito ang ating value for the angular rate. Lastly, for letter D, the vector expression for the total acceleration of the rocket. Ngayon, with unit vectors na E normal at saka yung E tangential natin for the normal and tangential directions, respectively, the total acceleration becomes, sabi ko nga, kapag in terms of vector, ang magiging answer natin for the total acceleration ay A is equal to 23.8 E normal plus 27.1 E tangential feet per second square. Ito na yung magiging sagot natin for the total acceleration in terms of vector expression, yung E normal and E tangential natin for the normal and tangential components. This is the letter D for example number 2. And that's all for the curvilinear motion tutorial video using the normal and tangential components. Please like and share, subscribe for more. Thank you for watching and see you on the next video.